This is CPM Calculus Chapter 4, number 45. So here we're asked to use Riemann sums with 20 rectangles to approximate the following integrals. And after we do that, use the numerical integration feature in our graphing calculator to check our answers. Alright, so let's go ahead and remember that when we were asked to find the area between our function and the x-axis bounded by A and B, it's approximately equal to sigma, which is our Riemann sum, starting at I, or any variable, I'm going to use I, equals to 0 to n minus 1 of delta x, which is the width of each region, times our function starting at A plus delta x I, again delta x is the width, and times I is our index here. And this is going to be the approximate area of our region, okay? And also remember that the width here is just b minus a over n, right? That's delta x, all right? So we can go ahead and approximate this then. This we know is the area, exact area under the curve, and this is the curve. So we could say this is approximately, right, or this is exactly the area between our function 2 minus 4x to the 3 halves, right, between, and our boundaries here, a and b, are 0 and 4. So between 0 and 4, okay? And then we know that that now is approximately, and again we're using 20 rectangles, so that is n. N is equal to 20, right, where we see n. That's equal to then approximately I is equal to 0 to n minus 1 is 19. Delta x, well, what is delta x? Let's quickly do that. Delta x, I'm going to write it in a bubble here, is b minus a over n. And b minus a is 4 minus 0 over 20, right, which is 4 over 20, which is 1 over 5, or 0.2, okay? So that's my delta x. Alright, so I'm going to go ahead and write that. Again, I'm just going with this formula here, you could say, or you just remember that it's the base and height of every rectangle. So again, delta x is 1 over 5, or 0.2, times our function starting at a. Well, a I know is 0, right? 0 plus delta x times I. And delta x I already found is 1 over 5 times I. Okay? And if I plug this into my function, so this is the input to our function f, that's going to give us, I could say equals because I already said approximately once, or I could keep saying approximately, same thing. Starting at 0 going to 19, 1 over 5, and now if I plug in, this is the input to the function here, right? So it's going to be 2 minus 4, and instead of x, I have 1/5 I to the power of 3 over 2. Okay? And now I can use my calculator to go ahead and compute this for me, right? I go up here to calculate, and I have a sum. And here I put my expression is this, so it's 1/5 times, in parentheses I have 2 minus 4 times, in parentheses again I have 1 over 5 times I, and so I'm going to use, remember, make sure to use this I and not the imaginary I, okay? So 1 over 5i to the power of, and I'm going to put the power in parentheses, 3 over 2, because if I don't, it's going to just put to the power of 3 and then divide it by 2. So I put that, close the parentheses that I opened here, starting at 2, comma, I put the variable, well, I used I as the variable, so alpha I again, comma, my starting point is 0, right? My stopping point is 19. So comma 0, comma 19. And I'm going to use the green diamond, enter, to get the approximate answer, which is then, I'm going to say approximately now, 96.0764. Alright? And I know that oops, I just see I made a mistake here, right? This should be 1/5 times 2 minus 4. So let me go ahead and correct that. 1/5 right here should be 2 minus 4. Alright. Alright, that looks right. I'm just checking that it's correct. 2 minus 4, yes. So that's not 96, excuse me. That should be negative 40.0382. Okay, so let's write negative 40.0382, and that's units squared. Okay, so that's the area that we get, and that's approximate using our Riemann sum. So let's go ahead and use our calculator to get the exact area. Okay, so if we were to plug this in our calculator, how close are we? So let's do that. If we push F3 again, this time let's go to integrate, right? And let's put in this now is the expression 2 minus 4 times x to the power of 3 over 2. Again, put 3 over 2 in parentheses, comma, our variable is x, comma, now our starting and stopping is here, 0 and 4, so comma 0, comma 4. Close that up. Okay, so that's going to give us approximately, so I'm going to put the diamond and enter again to get, that gives it exact. I'm going to do it to get, like, the approximate answer. So it's negative 43.2 units squared. Okay? So you can see using 20 rectangles, I get negative 40.0382. The exact area, though, is negative 43.2 units squared. All right. Let's go on to part B. Part B, here's our function. This time we're starting at 1, stopping at 8. And let's go ahead and look at this. This is equal to the area bounded by the function 4x plus 3 between 1 and 8. Right? And we could estimate it using sigma notation. So we have sigma I is equal to 0, and we have 20 rectangles still. So that is going to be stopping at 19. Delta x, so let's again calculate delta x, is b minus a over n. B minus a is 8 minus 1 over n is 20, so that's equal to 7 over 20. So 7 over 20 is delta x, right? And again, I'm going to just be copying this, times the function starting at a. Now a now is going to be 1, plus delta x, 7 over 20, times I. Alright, so that is how we approximate it. We plug this in again. It's going from I 0 to 19, 7 over 20. Now I'm going to plug this into the function. So that's going to be times the square root of 4, and instead of x, we have 1 plus 7 over 20i plus 3. Okay, so I'm plugging it into our function. Now I can go ahead and put it in our calculators. Let's do that. So here we have the sum again. So 4 gives us the sum, option 4. And then we have 7 over 20 times the square root. So second times gives us the square root. And then in the square root we have 4 times, in parentheses, 1 plus 7 divided by 20 times I, alpha 9. close parentheses, plus 3, close the parentheses because that ends the square root, comma, our variable is I, and our index starts at 0 and stops at 19 because we're using 20 rectangles. Alright, diamond, enter, and I get this area is approximately 30.8472 units squared. Okay, you should get the same thing. Make sure you know how to put in your calculator, so follow along. If you get stuck somewhere, go ahead and let's talk about it in class or after school. So let's go ahead and now calculate the exact integral, right? We can use our calculator to do that too. So push F3, go to integrate, option number 2. The integral now is the square root of 4x minus 3, right? Close the parentheses because that closes the square root, comma, our variable is x, comma, our start and stop are here, 1 and 8. So we go from 1 to 8. And I'm going to use the diamond equals, so I get a decimal answer. And that's equal to 25.8616 units squared. Is that right? Yeah. Alright. Oops. I see I didn't do it right because I'm like, is that a big difference? This should be plus 3, right? So let me go ahead and fix my equation. So if you make these kinds of mistakes, it's good to go ahead and check that it's what you wanted after you entered it. This should be plus 3, so let me go ahead and do that again. Erase this, because the exact area is 31.4238 units squared. Alright, so this is how you do it on your calculator. Make sure to check because, like I just did, sometimes you might bump a key that you didn't mean to. Alright, so that's going to end for us CPM Calculus Chapter 4, number 45.